This is Tech Math 2, and we're going to do section 14.3 today. What we're going to do is we're going to multiply and divide imaginary numbers.
Anything on the screen there?
Okay. Now, imaginary numbers can be in the form a plus bi, or they can be in the form r angle theta, or they can be in the form r cosine theta plus I sine theta, or that could be a j. We'll be consistent and use j, I guess. Or they could be in the form r e to the I theta, j theta. So those are the four different ways that we can express an imaginary number. Now the issue is, how do we add, divide, multiply, divide and multiply those? Okay, so if I have the form a plus bi, and I want to multiply it by c plus di, then that'd just be brute force. That guy times that guy, him times him, him times him, him times him. If I have it a plus bi divided by c plus di, then I'd multiply top and bottom by the complex conjugate, c minus di, so that I rationalize my denominator, and then I do what I just did up here twice in order to get an answer on top and bottom. Now that seems like a lot of work. If I'm in the form r1 angle theta 1, and I multiply that by r2 theta 2, then I multiply the r's r1, r2, and I add the angles, r1 plus theta 2. If I divide, I have r1 angle theta 1 divided by r2 angle theta 2. Then I keep the magnitudes as r1 divided by r2, but my angle is going to be r1 minus theta 1 minus theta 2. If I'm in the form r1 e to the I theta 1, and I'm multiplying that times r2 e to the I theta 2, then that becomes r1 r2 e to the I theta 1 plus theta 2. And if I'm dividing e to the I theta 1 divided by r2 e to the I theta 2, then I end up with r1 over r2 e to the I theta 1 minus theta 2. And the last form is I got r cosine theta plus j sine theta 1, 1, 1. And I'm going to multiply that times r2 cosine theta 2 plus j sine theta 2. Then that ends up being r1 r2 cosine theta 1 plus theta 2 plus I j in case sine theta 1 plus theta 2. And guess what happens if I divide? r1 cosine theta 1 j sine theta 1 divided by r2 cosine theta 2 plus j sine theta 2, and I end up with r1 divided by r2 cosine theta 1 minus theta 2 plus j sine theta 1 minus theta 2. And now we're consistent in what we're doing. We're in all those things. Okay, enough of that. Enough theory. But that's what we end up doing. And, so now we're going to find some products. So I'll start with number 1. And I've got 4 e to the j 7e to the 3j. 28, when I multiply them together, I add exponents. What is the equal sign doing there? E to the 4j. So I multiply the magnitude, I add the exponents. Number 3, 9e to the 5j, 3e to the minus 3j. I multiply the 3 times a 9, I add the exponents. I think this is just a repeat of chapter 4. Number 6, oh, 3e to the minus 9.4j times 7e to the 6.7j. So that'd be 21 when I multiply the magnitudes, and I subtract these guys, and what do I get? 2.7j. All right, now we're going to do, let's see, find the product and write the result in rectangular form. Okay, so that's what we're going to do next. Number 7. 3e to the pi j, 8e to the pi j over 3. All right, so that'd be 24 e to the 4/3 pi j. And we want that to be in rectangular form. We recognize 4/3 pi. 4/3 pi as what? As 240 degrees. Yeah, I think we recognize that as 240 degrees. So that'd be 24 cosine 240 plus j sine 240. And let's say, what do we recognize that as? 24, the cosine of I think this is square root of, now this is a half, because the reference angle would be 180 minus 240, so a reference angle of 60, so that would be 1/2, but it'd be a minus a half, minus j square root of 3 over 2, and then we'd have that be minus 12 minus 12 square root of 3j. And then we could just put it in our calculator. So my calculator, what am I going to do? Okay, so I've got, look at my mode, I put myself in rectangular mode, now I'm in rectangular mode, and I say, well, if I have 24 second function complex angle 240, and I hit the enter button, my calculator is going to tell me that this is minus 12 minus 20.78j, and then I ask myself, what is 12 times the square root of 3? And that's the 20.78, so that's the same answer. So I took this guy and wrote him 24 angle 240. Put it in my calculator. Why my calculator was in rectangular mode, and I got the answer out. Okay, we're going to do number 16 each. Find the product and write the results in trigonometric form. So that's what we're going to do. 16. Okay, so we're looking at 16, and we have 6 cosine 240 plus j sine 240 times, and I'm going to run out of room, I just know I am, 3 cosine 300. That was unfortunate use of a parentheses there. Plus j sine 300. Alright, so we know what 6 times 3 is, so that'd be 18, and that'd be cosine of 540 plus j sine 540, and we probably wouldn't keep it in 540s, right? And so we say 360 away from 540. 540 minus 360. 180. Alright, so that'd be cosine 180 plus j sine 180. And that would be trigonometric form, and I would leave it there. But we know the sine of 180 is 0, so why can't I just write that 18 cosine 180? And why can't I just write that as 18? You know, seems like 18 minus 18 would be perfectly okay in this case, except it told me to give my answer in trigonometric form, which means I'm going to have to keep it up there at a higher level. Okay, so we'll do it again for problem 18. So I've got 8 angle 168 times 9 angle minus 215. Look at those angle signs, aren't they cool? Wonder how long they had to get to make the printer do that. Times 8, 72. 72 angle minus what? 168 minus 215 minus 47. So we don't really want a minus 47, so I'll add 360 to it, and 313. So 72 angle 313, but they wanted it in trigonometric form, so we'd have to have 72 times cosine 313 plus j sine 313, which teaches us that we should read the problem, right? Because if we don't read the problem, something will be wrong. Okay, we'll do number 20 next. And we want to write the result in rectangular form. Okay, so luckily my mode is already rectangular form, so I'm all set on my calculator to get there once I get it into a position where I can do that. Okay, so I got 4 cosine 105 plus j sine 105. What if I had cosine 110 plus j sine 95? I'd be hosed, right? And I'm not in the right form, it's not an imaginary number the right way. Yeah, exactly. So I could write it that way, but I'm not going to. 1 cosine 120 plus j sine 120. All right, so my problem's almost written right. And now my problem's written right. All right, so that being the case, 1 times 4 is 4. And I have the cosine of 225 plus j sine 225. And I could write that as 4 angle 225. And I could take my calculator, which is already in rectangular mode, and go for second function complex angle 225, and I could have minus 2.83 minus 2.83 j, And then I'd go back and say, wait a minute, the cosine of 225, the reference angle of that is 45 degrees, right? So this is really 4 square root 2 over 2 with a minus sign because I'm in the third quadrant, minus j, the square root 2 over 2, because again I'm in the third quadrant, and that becomes 2 the square root 2 minus 2 the square root of 2 minus j 2 the square root of 2. So there's nothing wrong with that answer there, but I should have recognized that this had a reference angle of 45 degrees and put the real things in at the beginning. But I didn't. All right, so 26. Write the result in exponential form. All right, so 6 e to the 3j divided by 4 e to the j. All right, so I got 4 goes out, it'd be 3 over 2 e to the 2j, because I'm subtracting 3j minus 1j, getting 2j. Number 29, I've got 8 e to the 1.6j, 24 e to the 3.8j, 1 over 3 e to the minus 2.1, 2.2j. Now at this point we could say, gee, I don't know that I want a negative exponent, right? But this is chapter 14, so there's nothing wrong with the negative exponent, so we'll just keep it. All right, we'll do number 36. And we want to find the quotient, and we want to write the result in rectangular form. All right, well, that's reasonable. That's 15 e to the minus 3.6j divided by 12 e to the minus 5.8j. Let's see, that looks like 5 over 4. 5 over 4 e to the 2.2j, 2.2j. All right, at that point, I would take my calculator, I'd put my mode in radians, because I know those are radians up there. And then I would go 5 divided by 4, second function, complex angle, 2.2, and I'd write down minus 0.736 plus 1.01j. And that's the way I would do that. Now, if I didn't want to do that on my calculator, I wanted to find some hard way to do it, then I would change the 2.2 radians into degrees, right? I would do that first, and then say pi radians is 180, as 2.2 is 2x, and x is 2.2 times 180 divided by pi. 2.2 times 180 divided by pi. So that's 126 degrees. And then I'd say, well, this is 5 over 4 angle 126. And then I'd put it in my calculator and I'd do the same thing. So, or I could go 5 over 4 times cosine 126 plus j sine 126. If I didn't want to put my calculator in radians, but I probably do, so I probably would. Okay, we'll do 38 next. Am I going fast enough? 38. 18 cosine 170 J170 divided by 2 cosine 70 J sine 70. All right, looks good. 9 angle 100. Now, what do we want to do? We want to write the result in trigonometric form. Okay, so I'm going to write the result in trigonometric form. 9 cosine 100 plus J sine 100. All right. If you insist, I will do it that way. All right, now, we'll do 42. 42. 54 angle 140 divided by 9 angle 350. Better put degrees there so we don't forget and think it's radians. Let's see. So that's 6 angle minus 210. And we're supposed to be, our result's supposed to be in trigonometric form. Minus 210 would be 6 angle 150. Is that what it is? Yeah, okay. So 6 angle 150 is trigonometric form. 6 cosine 150 plus J sine 150. Would there be anything wrong writing it 6 cosine minus 210? No, it's spelt wrong. It would depend. If we're on the final exam and Ben had 100 up to that point, then it'd probably be minus 0.1 at that point. But the rest of you, it probably wouldn't matter because you already missed something. So that's probably how that would work.
Are you kidding?
Huh?
Are you kidding? 100 up to this point?
That's right. So it wouldn't matter because it wouldn't be 100 unless this was the very first question.
There you go.
Yeah, and then you could have 100 up to this point. Yeah, you have a point there. Yeah. Okay, we'll do.
You got this at least something on every part.
Yeah, this is. We're running out of problems to do. This is pretty disgusting, isn't it? All right, 43. Maybe we'll have everybody just go to the board and solve a problem. Write in rectangular form. Okay, so I got 72. 72 cosine 240 J sine 240 divided by 8 cosine 120 J sine 120. So what is that? 9 cosine 120 plus J sine 120. And we recognize that as reference angle 30. So it'd be 9 times minus a half plus J square root of 3 over 2, right? Yeah. And so it'll be 9 halves plus 9 over 2 square root of 3J. And that'd be perfectly okay, leaving it like that. Okay, we'll do 48 next. And what we're going to do, first thing we're going to do is just take our calculator and put it in our calculator and see what it says. So if I go, I'm going to make sure my mode is in polar mode. So I'm in polar mode, and I got 80 second function complex angle 30. I hit the wrong button. 80 second function complex angle 30 divided by 25 second function complex angle 300. Error type, I'm going to error type you. All right. Insert a parentheses, insert a parentheses, insert a parentheses, End it with a parentheses. All right, what do you think about that? There we go. That's much better. So I've got 3.2 angle 176.9682 is what my calculator is telling me. Now, why would the calculator tell me such as, oh, I'm in radians. Oh, bummer. I'm in radians. All right, so back to mode, degrees. All right, get out of that. Always look up, see what you're in. Parentheses, 80 second function complex angle 30, close parentheses, divide by 25 second function angle 300, close parentheses, boom. Error type. What'd I do? Oh, I left out a parentheses. Insert a parentheses. All right, there we go. Oh, that's much better. Now I have 3.2 angle 90. And I want the answer to be in rectangular form, so it would be 3.2J. All right, so that's what my calculator, oh, did I want rectangular form? Why didn't I just put my calculator in rectangular form? All right, so that's what I'm going to do. Back to mode, back to rectangular mode. I'm in degrees still. All right, so I'm going to go parentheses, 80, second function complex angle 30, close parentheses, divided by parentheses, 25, second function complex angle 300, close parentheses, equals, oh, look at that. The calculator says 3.2J. Actually, it says I, but same thing. Okay, so I'm not going to do it in my calculator. I'm going to do it different now. I'm going to say 80 angle 30 divided by 25 angle 300. And I'm going to divide both top and bottom by 5. And 5 goes into the top 16 times. 16 divided by 5. And at an angle of minus what? Minus 270. And I recognize that as 3.2 angle 90. And I change that to rectangular form, 3.2J. Okay. Oh, bummer, look at 50. What are we going to do about that? Number 50. 3 cosine 150 plus j sine 150 cubed. All right, well, we'll put it in a different form. 3 angle 150 cubed. 3 cubed is 27. 150 times 3 is 450. 450. 27, subtract 360, that's angle 90. And we want to have the result in rectangular form, so my answer is going to be 27J. Now, let's see if my calculator will do that. I check my mode. I'm in rectangular mode, and I'm in angles. Okay, so that's fine. So I come back up, parentheses, 3, second function, complex, angle 150, close parentheses, raised to the third power, 27J. Yay, calculator. There's harder ways to do that problem, but I would not suggest doing them any of those harder ways. Number 52, 2 cosine 315 plus j 315 raised to the 4th power. All right, so that's going to be 16 angle 4 times 315. All right, well, 315 times 4 equals minus 360 minus another 360 minus a third 360, and we have 180. All right, so this is 16 angle 180, and we want it to be in rectangular form, so that's going to be minus 16J. And with that, we're done with chapter section 14.3. So let's see that we have some time. Why don't we figure out the 27 nth roots of 1. Okay, so I'm going to take 1 to the 27th.
That's not till the one.
Huh?
So that's not till the one.
Yeah, but we have enough time. We have 10 minutes to work the problem today. All right, so this is 1 angle 0 raised to the 127th. All right, so it'd be 1 angle 0. So we got one of them already. This is 1 angle 360 raised to the 1 over 27. So that'd be 1 angle 360 divided by 27. 13.3 repeating degrees. That's 1 angle 720 raised to the 127th. 1 angle 26.6 repeating. Do we see a pattern yet? 1 angle, well, it's not going to double the next time, but I'm going to add 13 1/3 every time.
Wow.
Okay, plus 13 plus 1/3, 40. 1 angle plus 13 plus 1/3, 53.3 repeating.
So how high up would you go with?
1 angle, well, I need 27 of them, so I'd have to write all 27 of them down. And then when I got to the 28th one, it'd be 1 angle 360, which is the same as 1 angle 0. Yeah, plus 13 plus 1/3. Oh, this is my favorite one, 66.6 repeating. 1 angle 80 degrees. And they just keep on going forever and ever. 1, you think of 1, the square root of 1 is 1, the third root of 1 is 1, the fourth root, but not in imaginary numbers. The cube root of 1 has 3 different numbers associated with that it could be. And the 27th roots of 1, there's 27 of them. All right, so did we bore you enough with that? Goes on and on and on and on. Maybe